Video, we will discuss two-dimensional arrays using Raptor. I am Dr. P.V. Sena from CBIT. So the basic symbols which we are using here it is start and stop symbol, processing, input-output symbols, flow lines, decision making, and connectors. At the same time, we are using the loop in order to maintain the arrays. So in order to maintain a single dimensional array, we are using one-dimensional arrays. In order to maintain a two-dimensional arrays like a matrix form, a grid structure, we are using a two-dimensional arrays. Already you know that the array is collection of similar data type or homogeneous values. These arrays are used when program models data laid out as a grid or matrix format. Suppose if you need a grid format or matrix format, then we need to use a two-dimensional arrays. While one-dimensional arrays are indexed by a single value, two-day arrays have two indices, separated these indices by comma in a square bracket. So the example is grid square brackets 3 comma 4, 3 rows, 4 columns. So 3 rows, here first row, second row, third row. The fourth column, 1, 2, 3, 4, 4 columns. Grid 3 comma 4, 3 rows and 4 columns. The number in the square brackets are row and column indices. First one is the row indices, second one is the column indices. 3 rows and 4 columns. So the 2D array called a grid as below, where the names of these array elements are shown in this diagram. Always this I comma j will refers the indices. Suppose if you take I comma j variables which are representing the indices a of I, a of j, array of this a of I and a of j, this will represents a single dimensional array. Array of I comma j, this will represents two-dimensional array. So array of I comma j, I rows and j column represents the values at that memory locations. Assume that A is an array. Always I comma j are the variables which are representing the indices. A of I, A of j, this will represent a single dimensional array. Array of I comma j will represent two-dimensional array. I rows and j columns. So this times I'm showing sample values in the variable memory locations. So now 1 comma 1th location, the value will be stored 3. 1 comma 2nd location, the value is 8. So 1 comma 3rd location, the value is 6. 1 comma 4th location, the value is 15. So in the Raptor, the index is starting with 1. So this is how the values are stored in the memory locations. Always I comma j will represent indices. A of I comma A of j will represent the values at that particular memory locations. So reading a 3 by 3 matrix and display it. So idea behind it is, so the number of rows here it is 3, number of columns is 3. So array of 3 by 3, 3 rows and 3 columns. So this is my matrix A with 3 by 3 ordered. So what are the values at that memory locations? So 11, what are the values at that memory locations means 11, 22, 33, 44, 55, 66. 77, 88, 99. So this is my 3 by 3 matrix. This is my 3 by 3, 3 rows and 3 columns. Right? So this is my 3 by 3 matrix. So what is my intention? I need to read a 3 by 3 matrix and display this 3 by 3 matrix by using two-dimensional arrays. So the algorithm or the procedure we are following here it is to read a 3 by 3 matrix and display it. Initialize an empty 3 by 3 matrix. Create a 2D array to store the elements. Example, a array of 3 comma 3. In Raptor, these indices are separated with comma in square brackets. In programming language, array of 3, again you need to write a square bracket for these 3. Right? And that is in programming languages. Loop through the rows. Right? Use outer loop, I loop for iterate over the rows of the matrix. So always this outer loop or I loop is operate on the rows. So the inner loop or J loop for each column. Yes, this is operate on the columns. The user input these values. So outer loop will represent the rows. The inner loop will represent the columns. Store these values in a matrix corresponding rows and columns, array of I comma j. So display this matrix. Once all values are entered, display the matrix in formatted way. Flowchart to read a 3 by 3 matrix and display it. So the matrix elements here, I is 1, So we are reading this elements A of I comma j. So matrix here it is in raptor I comma j, I row and jth column. The element is readed. After that one, I am incrementing the inner for loop by j is equal to j plus 1. At the end of this one, I am incrementing this outer for loop I is equal to I plus 1. At the same time, I am displaying the elements here only. So I am using two for loops. The outer for loop will represent the rows and inner for loop will represent the columns. So once you are reading the element a of I comma jth location, this particular row and column location, you are placing the elements. After that one, you are putting the element a array of I comma j. Then you are incrementing the inner for loop by j is equal to j plus 1. At the same time, you are incrementing the outer for loop I is equal to I plus 1. So in order to space adjustment, we are using this output symbols. So this is my output. So flowchart. So I am reading the elements is 11, 22, 33, 44, 55, 66, 77, 88, 99. So once I am reading the array elements, I am displaying this array elements by using this order. So this is enter flowchart, reading the elements and displaying the elements to read a matrix 3 by 3 matrix and display that 3 by 3 matrix. So in this way, you can find out transpose of the given matrix. So the transpose is you convert rows as columns and columns as rows. Then it is said to be transpose. Then check symmetric. So once you are finding the symmetric A power T is equal to A, then that matrix is said to be a symmetric matrix. Next, you can try addition and subtraction of the given two matrices. Thank you, children. Thank you for listening.